Hi everybody. I'm going to be doing a video about explaining the lesson 7-7 by going over a couple of the examples before the homework pages, and then I found a couple homework questions that I will show you how to do too on paper. So the big idea about this lesson is that you're seeing the relationship and the connection between a geometric sequence and how they are exponential functions, how you can write an exponential equation about them. So the first thing I noticed that you could all make a connection to up here, at any point, if I'm talking too fast or going over stuff too fast, just pause the video, look over stuff in a little bit more detail, and then start it back up again so you can stay with me, okay? So this example here is of how, exponential growth happens, like you learned in the last couple lessons. It says the first person generates 5 emails. If each of those people sends an email to 5 more people, so times 5, 25 emails will be generated. If each of those 25 people sends 5 emails, 125 emails will be generated. That's an example of a geometric sequence. Okay, so geometric sequences, it's when you see a pattern that's being multiplied by a constant number, or you'll see it's being divided by a constant number if the number's decreasing in the sequence. So it's all about, if you notice a pattern, that's multiplication or division. Okay, but not just adding or subtracting. If you're just seeing that it's just up plus 5, plus 5, plus 5s, that would be an arithmetic sequence, and that's what we learned about earlier this year when we were together. So an important thing to know about that is I'm trying to see where it talked about. I'm not sure where it first introduces it, but when you're finding, the common ratio, like for this one up here would be 5, because that's the number that you're multiplying by. When we get into these questions in more detail, you'll see that the common ratio is always has to be what you're multiplying by. So, a question might come up, well, what if I divided, like right here, right away? What if I noticed the numbers were going down, and I said, oh, it's dividing by 2, dividing by 2, dividing by 2. Well, you have to think of that in terms of multiplication. In order to get the common ratio, you have to think of what you're multiplying by to go from the left to the right, and so on. So, dividing by 2, if that's what you notice first, you have to realize that that's the same as multiplying by a half. So I just wrote down that real quick. When you divide by 2, now you can see that's the same as multiplying by half, right? It's multiplying by the reciprocal, back several years ago when we first were introduced to that. Same if you notice that the pattern is divide by 3, divide by 3, divide by 3. Well, you need to think of that more in terms of multiplication. That's the same as multiplying by a third. All right. So the first couple examples in your book just are about you determining what kind of sequence it is. Arithmetic, I just reminded you, that's when you're adding by the same amount through the sequence or subtracting the same amount through the sequence. Geometric is when you're multiplying or dividing by the same number throughout the sequence. And then sometimes the sequence, it won't be either, right? So that's what you had to do in the first few problems on your homework, is just determining that. And your explanation can be, if you think it's geometric, go prove it by saying what the common ratio is. And again, the common ratio is just the number that you found you can multiply as you go from left to right. What's that common same number that you're multiplying by the whole time, right? And then I think you will be good to go on the next section too. It's just they're asking you to find the next 3 terms in a geometric sequence. So of course you have to find the common ratio first, and then you'll just continue to do that. So here, there is a study tip here that says if you ever do notice that the numbers are going from positive to negative to positive to negative, that's a clear sign that your common ratio has to be a negative. When you multiply by a negative number, won't it constantly go back from positive to negative and so on? So watch out for those. So see how you can just find the common ratio. And then so the last number given was negative 64. So you can just continue to do that times negative 4, and that's what they did here in step 2. And you'd get the next 3 numbers in the sequence. Okay. But if you're having trouble with lesson 7.7, it might be because of the final example, which was about you writing equations, writing exponential functions for these geometric sequences. So that's what I'm going to look at with you next. So they introduced to you this new equation, okay, where they told you this represented the first number in a sequence. R stood for the common ratio. And then, if I asked you to find, I've talked to you about this in terms of arithmetic sequences. You don't want to have to go write out. If I said go find the 100th term, what would be, like to this problem right here. If I said, go tell me what would be the 100th term of this sequence, you would never want to have to go write out all the first 100 terms of the sequence. So we learned when we did arithmetic ones that you could go and there was an equation you could use. Well, same for geometric ones, okay? So this was the equation that was brought to you. And the reason how it works, I wanted to show you real quick, is, up here, they're telling you, like I said, if you wanted to find the 100th term, 100 would go in here for the term number. So you do 100 minus 1, so the exponent here would end up being 99. Okay, why are you doing that though? So in this table, they showed you if you wanted to get the real data and put it in, you would see that the exponent you're always going to, the power you're always going to have with the common ratio, it's always going to be 1 less than the term number. So see how this term number was 4, but the exponent's 3. This term number's 3, the exponent's 2. This term number's 2, and the exponent's 1. Okay, so every time you use this formula, you're going to take 1 away from the term number, and that's going to be your exponent. That's going to be your power that you're going to take to the common ratio. Okay, so there it is right there. Alright, so on page 441, which was where your homework was, I just picked 2 problems we could look at. Number 17 just simply asked you to find out whether it was geometric, arithmetic, or neither, and then explain. So number 17, I could tell that the numbers were decreasing, so I knew I had to be multiplying by a fraction, okay? And some of you very quickly can tell you're just dividing by 2, right? It's just half of it each time. So dividing by 2, we talked about, is the same as multiplying by a half. So that is constant, and you are multiplying or dividing, so that does make it geometric. And then your reason, it can be because the common ratio is a half. Okay, so that was for number 17 on page 441. And then I chose number 29, 29, they asked you, it says, what is the 10th term of the geometric sequence 6, -24, 96? So step 1, as they showed you in the examples, is that you have to find the common ratio first. So there's one of those where you're going from positive to negative to positive, so I knew I had to be multiplying by a negative something to make that happen. And it ends up being times -4 times -4. So again, the question was, what would be the 10th term of the sequence? So I had to go use our equation here, and I had to go input everything we were told. So 6 is here because that's representing the first term. The first term is 6. It's just the first number of the sequence. The common ratio, R, would be -4. And then the term number they're asking about is the 10th term. What would be the 10th term? So again, if we would have continued this pattern till we got to the 10th number, what would it be? That's the question. And this is the equation you can use to just find it without having to make a long list. So when I start solving, I'll of course do 10 minus 1 and have an exponent there of 9. Before we left school, I mentioned this to you. I remember we've talked about it a couple of times this year, but when you use that calculator, which you definitely will, make sure that you are putting -4 in parentheses. If you just type in -4 to the 9th power, sometimes you'll still get it right. We talked about that, but please remember to put parentheses around the negative. So if the exponent's an odd number, remember we said you'll still end up getting the correct answer. But if the exponent happened to have been a positive number and you don't put that negative base in parentheses, you'll end up the outcome would be wrong. So just always put the negative number in parentheses, then to the power of 9 for this one. So it became that small number, and I still have to times 6, and I got that answer. Again, this is number 29 on page 441. Alright, so as we've been doing, yes, you had homework in your book covering the geometric sequences, and then there'll be a homework or a worksheet too. So please just let me know if there are more problems that I can video and show you. Just let me know. Email me, put it on Google Classroom, and I'll make you another video. Thanks, bye.